Plugging brake systems. In this presentation, we're going to be looking at the parts and components of a plugging brake system, concept of operation, centrifugal switches, common control circuits, and finally a few summary points. In order to assemble a plugging motor braking system, we only need a few off-the-shelf components from the local wholesaler, a forward reversing starter, and either a zero speed switch or a time delay relay. The application of plugging brakes is to reverse the phase rotation to the stator winding of the motor while the motor is still turning. This causes a counter torque to be developed by the stator field as it attempts to turn the motor in the reverse direction. Once stationary, the motor must be immediately de-energized. Otherwise, it will then start to turn in the reverse direction. And we use a forward reversing circuit in many different iterations, depending if we want to have plugging brake applied in the forward direction or the reverse direction, or perhaps even both. When the motor is running, we have A, B, and C energized to the stator windings for whatever direction the motor is intended to turn. While we apply plug braking, all we're doing is reversing two of the phase connections to the stator winding. It's still energized and must be de-energized once the motor comes to a stationary position. We see this type of braking applied to large, heavy centrifugal type or high inertia type loads like in steel manufacturing, steel coils, paper manufacturing, paper rolls, as well as very large saw blades, probably not on a smaller assembly like this, but in the larger mechanized or automated sawmills where we have massive saws and we don't want those simply spinning after they've been turned off for prolonged periods of time. There are four common variations of control for plugging brake systems: a time delay on de-energization relay, zero speed switch and control relay, and finally a zero speed switch and lockout solenoid. This is a plugging brake system with time delay on a de-energization relay, and the contact is shown at the bottom as well as the time delay relay. Time must be set precisely for this particular type of control, and that's due to it determining the total deceleration period. Since the size of the mechanical load driven will affect the total stopping time, this braking control can only be used with the same load every single time. If the time delay were set too long, the motor would finally come to a stop but then start turning in the reverse direction. If the time delay was set too short, the motor would slow, but then braking would be released before it ever reached a stationary position. Let's take a look at a plugging brake system with time delay on de-energization relay and its operation. We first press the start push button, which energizes both the forward and the time delay relay. At this point, the motor is now turning in the forward direction. And we have a holding contact in the start portion, which keeps the forward and time delay energized. And you'll notice that the time delay contact changed states immediately because this is a time delay on de-energization. Once we press the stop push button, the forward coil de-energizes at the same time that the time delay de-energizes. At this time, the motor is energized in forward and motor is turning in forward. But as soon as the coil de-energizes and the contacts change state, the motor is turning in forward, but now it's going to be energized in the reverse direction. So now we have the reverse magnetic field direction rotating around the stator, and we have a time delay, and it's going to slow the motor until eventually it comes to a stationary position, at which point the time delay relay times out and the time delay contact opens, thereby de-energizing the motor fully in its stopped position. Now, as we said, this type of control can only be used with a known mechanical load so that you can accurately determine how much time the time delay relay must be set to. And that brings us to the other type of centrifugal control, or speed switch control for a plugging brake assembly. Centrifugal switches, also known as plugging, there are anti-plugging centrifugal switches, and they're also known as zero-speed switches. It's a pretty basic premise, one in which, in a stationary position, the toggle is not in contact with either of the other two terminals on the assembly, either here or here. It stays in the middle. When we spin the shaft one direction, and not necessarily clockwise, but one direction, one of the contacts will then close due to the centrifugal forces of the shaft being spun. If we were to spin it in the opposite direction, the other contact would then close, and again, if I were to simply have it stationary, our normal position would be maintained. A plugging brake system with zero speed switch uses the speed switch in lieu of having a time delay relay and contact. In this way, the centrifugal switch will then determine the amount of time that we have for braking, and that's going to be utilized automatically for any size of mechanical load. Since the larger the mechanical load, the larger the inertia and the longer that the centrifugal switch would be engaged. Large mechanical loads will have a longer plugging time applied, while small mechanical loads would have a shorter plugging time applied. Let's take a look at a plugging brake system with zero speed switch in its operation. We first press the start push button. It energizes the F or forward coil, which then changes the contact states, and the motor is energized in forward. The motor then starts to turn in forward, and what you'll notice is that the centrifugal switch has now moved, and it's moved because it's connected to the shaft of the motor. Now we're going to release our start push button, and you'll notice that the reverse coil is prevented from being energized due to the electrical interlock contact that's inserted there from the forward coil, this one right here. When the stop push button is pressed, it first de-energizes the forward coil. And when it does this, the forward coil will then drop the contacts back to their normal state. At this point, the motor's turning in forward, but it's not energized for a brief second. Now, the reverse coil will be energized, and once the coil is energized, its armature moves, the contacts change state, and what we have is a motor that's energized in the reverse rotational direction while the motor's turning in forward. Now, the rotation of this will slow as the counter torque is applied from the stator, and of course, we said the length of time the motor is plugged would be determined automatically by this speed switch, which correlates to the inertial energy of the mechanical load. Eventually, we're going to reach a speed where eventually we get almost to a stop, and our centrifugal switch will then drop out. The coil will de-energize, the contacts will go back to their original state, and due to that, the motor is now de-energized. So plugging brake system with a zero speed switch is actually quite handy, and it can be used with any size of mechanical load. There is, however, a rather significant drawback, and that is what happens when the mechanical load shifts or something moves the shaft of the motor. Well, if you were just to come along to this motor and give it a quick spin in the forward direction, what you would find is that we would close the centrifugal switch contacts, and that would immediately kick the motor into the reverse direction, turning it on. Now, that of course would immediately cause centrifugal switch to open, but you get the idea that this would be an unintended energization of the motor, could cause damage, could be a hazard for any individual in the area. In order to counteract this, there are two different variations of a zero speed switch plugging circuit. The first one is to utilize a control relay interlock. Instead of having the centrifugal switch simply connect into the reverse coil, we have it energizing a control relay, which has the interlock set up so that even when the motor's at a stationary position, if we were to come and rotate the motor shaft, the contacts may close here, but due to us having an open and an open, there's no way that we could possibly have the reverse coil energized and the motor inadvertently energize in reverse direction. Another form is something called a plugging brake with zero speed switch and lockout solenoid. And that's where we have a separate lockout solenoid that is connected at the motor terminals. Now, the only thing that shows this in the schematic is a separate little diagram off to the left-hand side, and they're simply showing a solenoid that's connected to T1, T2, T3, which means it will be energized whenever the motor's energized. Let's see how this works. Both of these items are inside a specially built zero speed switch, and there would be electrical connections for both the speed switch and the lockout solenoid. The lockout solenoid is really an operation of mechanical blocking. It's a 208 volt or a line voltage solenoid that connects into the power circuit right where the motor is. And all it does is it locks a shifting disc or lockout disc in place. So its normal position is pin up when de-energized. And you'll notice here that when the pin is up, the movable centrifugal speed contact is connected to the disc, meaning if the disc can't move, the contacts can't change state. Now the motor shaft can spin slightly inside the lockout disc. And so even if the motor was turning, the disc would remain stationary, and because of that, the contacts would not move. If we were to energize the coil, like what would happen when the motor is first turned on, the pin would then drop, the disc would be permitted to move in whatever direction that the motor happens to be turning. And so in this way, the speed switch contacts are immobilized when the motor is de-energized. This prevents mechanical rotation of the motor shaft from accidentally starting the motor. So it's simply another way that we can use a centrifugal switch and prevent the operation of this inadvertent energization and movement of the motor shaft. This is an example of a forward and reversing plug braking setup, where we have a centrifugal switch, but now we're actually using both the forward and the reverse to control two separate relays, which are then inserted into both the forward and the reverse circuits for this motor. So this is a clever adaptation where we have full forward and reversing control with push buttons, but we also have forward reversing plug braking applied. And finally, a rather more complicated setup where we have a forward and reverse and jogging. And remember, jogging is something that allows for the very momentary energization for short periods of time of the motor. And it's something that does not utilize the holding contacts. Plugging brake systems are used to very quickly slow the motor by reversing the phase sequence to the motor stator. They require a control system that will de-energize the motor the instant it stops. Otherwise, it will continue to run in the opposite direction. Plugging brake systems can be used on any type of motor that can be reversed by changing the wiring connections. And finally, we can apply zero braking force when the motor is stopped. And what that means is that the motor shaft can easily turn once it's in a stationary position. There is nothing holding it there or applying maximum braking force.